solving trig equations with unlike terms. And for these, we're going to need to use a substitution. So the first video will be using a Pythagorean identity substitution. I am not going to go over all three of the Pythagorean identities. I will just go over which one would be most used. So the Pythagorean identity that we will use comes from the unit circle equation. And so if you'll go back to one of the very first standards that we talked about, which is the unit circle equation, and that equation was x squared plus y squared equals 1. So x squared plus y squared equals 1. But by this time you should understand and know that x is known as cosine and y is sine. And so this is the Pythagorean identity that we will use. Cosine squared plus sine squared equals 1. Now for the substitution purposes, we're going to rewrite that and solve for cosine squared. And if I were solving this for cosine squared, I would subtract sine squared theta from both sides. And so that will give me the first one that could be used, and that is that cosine squared theta is equal to 1 minus sine squared theta. And if I would prefer to solve it for sine squared, then I'm really going to do the same thing. That is subtract cosine squared theta from both sides. And so I'm left with sine squared theta equals 1 minus cosine squared theta. So those are the two Pythagorean identities that you will use for substitution. So next question that you should have is, how are you going to know when you need to use those? So here's an example of an equation that would require one of those two substitutions. As I've mentioned and has been mentioned in previous lessons in this unit, you've got to set the equation equal to 0 before you can really go about solving it. And so for this one to be set equal to 0, it's 0 equals sine squared theta plus 2 cosine theta minus 2. And how do I know that I need to use one of these Pythagorean identities? Well, I have a quadratic. I've got a term that's squared, but the problem is I can't use just going into the quadratic formula or into factoring because I have unlike terms, meaning I've got a sine and a cosine within the equation. So I've got to substitute in for either one of those two trig functions. This is what you know, that you will substitute in a Pythagorean identity into the term that is squared, because our Pythagorean identities are also squared. So I'm going to replace, substitute in for the sine squared, its equivalent, which is 1 minus cosine squared. So I've got an equation, and in place of sine squared, I'm going to put 1 minus cosine squared theta plus 2 cosine theta minus 2. Once I've done that, I now have an equation that is in all a common trig function, which is cosine. So I'm going to reorganize a little bit. So 0 equals negative cosine squared theta plus 2 cosine theta, and then I'm going to combine this positive 1 and this negative 2 and get minus 1. If I would like to try to factor it, then I'm probably going to want to change the squared term into a positive, and all that does is change the signs of everything else. So cosine squared theta minus 2 cosine theta plus 1 is equal to 0. This looks to be factorable. Let's factor. Cosine theta has to go in the front of each. And my only possible choice for the second term in each binomial is a 1. I have a positive 1, so I know the signs are going to need to be the same, but a negative 2, which tells me both of them would have to be negative in order for this to work. So a negative 1 times a negative 1 gives me a positive 1. If I do my two little smileys, I end up with negative 1 cosine theta, and this one gives me negative 1 cosine theta. If I combine those together, I have negative 2 cosine theta, and so it did factor into cosine theta minus 1 times cosine theta minus 1. So now I'm going to go about solving. That leaves me with cosine theta minus 1 equals 0. Cosine theta equals 1 after I add this 1 to both sides. I can use my calculator, but the question is being asked, what angle has an x value that's equal to 1? There is only one on the unit circle, and that is at 0 degrees, or 360 degrees. If I use 360 and it's asking about radian measure, that would be 2 pi. This would still be 0. That's using Pythagorean identity. Let's go through one more example. Negative 2 plus cosine squared theta equals 2 sine theta. So I'm going to get everything on the same side of the equation and set it equal to 0. So I'm going to move the 2 sine theta over to the other side by subtracting 2 sine theta. That leaves me with negative 2 plus cosine squared theta minus 2 sine theta. I have a cosine and a sine in the same equation. There's no GCF to be factored out. Sometimes you can have two different trig functions, but you can factor GCF out and it solves the problem. There is no GCF for all three terms, so I cannot solve the problem that way. So I'm going to have to use the Pythagorean identity, and I know that I need to use the one that replaces the squared term because our Pythagorean identities are squared, so I'm going to use the one that replaces cosine squared theta. So I've got negative 2 plus, and in place of cosine squared theta, I'm going to put 1 minus sine squared theta minus 2 sine theta equal to 0. I'm going to kind of reorder this, put my squared term first, put it in descending order. Didn't really have to have the parentheses, it didn't matter that I did or didn't. So I've got a negative sine squared theta minus 2 sine theta, a negative 2 and a positive 1, which is negative 1 equals 0. Again, I'm not a real big fan of having my squared term as a negative, so I'm going to change that to a positive, which means everything's going to change signs. Is this going to be factorable? Well, it's very similar to our last equation. It factors into sine theta times sine theta. That's how I get sine squared. And this is a 1, so these have to be 1s. That's a positive. They either both have to be positive or both negative. In this case, since the middle term's positive, they both need to be positive. So again, we've got the same binomial twice. Set that equal to 0. Sine theta, subtract 1 from both sides, equals -1. Where on the circle does sine theta equal -1? Where's the y value? -1. If you go back to your circle, that only occurs at 270 degrees. In radian measure, if it asks for radians, that's 3 pi over 2.